So here I have drawn the figure of this triangle using the given information. That is angle Y. I have marked this as a right triangle with a tiny little square. So this means this triangle is basically a right triangle since the angle Y is 90 degree. And I have also labeled as well as marked the other measurements like angle X is 61 degree, the side length XY is 12. So let's determine the unknown side lengths as well as the angle. So first I'm going to determine this angle Z. This can be determined using the angle sum property of a triangle, which is basically sum of all the interior angles of any triangle equals 90 degree. And this means angle X plus angle Y plus angle Z equals 180 degree. Now we can substitute the values of angle X and angle Y. Angle X is 61 degree, angle Y is 90 degree, plus we have to find the angle Z. This equals 180 degree. So this gives angle Z equals, this is 61 plus 90 is 151. So we subtract 151 from both sides, and this gives angle Z equals 29 degree. So I mark this angle Z over here. That is angle Z is 29 degree. We will now determine the side length zy, and this can be determined using the trigonometric ratio tangent. So I'm going to determine tangent of 61 degree. Remember that we can use this SOHCAHTOA. So according to the SOHCAHTOA, the tangent ratio is opposite by adjacent. So for angle 61 degree, the opposite side length is zy. Therefore, I write down this as in fact, I can write down this as yz. This is side length yz divided by the adjacent side is the side length xy. Now we substitute xy. The side length xy equals 12. So I can replace this as 12. Now we have to solve for yz. We multiply both sides by 12. This gives us the side length yz. So therefore the side length yz equals 12 times of tangent of 61 degree. We plug this into the calculator, and when we do that, we get approximately 21.6. So let me mark this as the side length for yz. So now this is 21.6. Now we will determine the side length xz using another trigonometric ratio. That is, we are going to use the cosine of 61 degree. According to SOHCAHTOA, cosine ratio is adjacent side over hypotenuse. So I'm going to find cosine of 61 degree, and this equals adjacent side to angle 61 degree is xy. So I write down this as segment xy over the hypotenuse is xz, the segment xc, and we know that xy equals 12. So therefore this can be replaced as 12, and this means we can now solve for the segment xc. So therefore the segment xc equals, we first multiply both sides by xc, then we will have xz times of 61 equals 12. So therefore we can solve for xc. We have to divide both sides by cos of 61. So therefore xc equals 12 over cos of 61 degree. And when you plug this into the calculator, we get the approximate value to one decimal places as 24.8. So therefore I can write down this as segment xc as 24.8. So we found the value of angle z equals 29 degree, and the segment yz equals 21.6, and the segment xz equals 24.8.